Hi everyone, this is Rita from XGeeks. It's nice to see you again. It's always nice to spend our afternoons at least once a week with you. So I'm super excited again to be here for one more of our live streams. And before anything else, if you're new to our channel and to our live streams, welcome. We're super happy to see you here. And if this is not your first live stream, we're extra happy to see you here because it means that you're enjoying our content. So we thank you and we appreciate having you here again. If you're one of the people that are watching this afterwards during the recording, that's awesome too. And we want to thank you also for joining us for today's live stream. And as you know, this is XGeeks channel. So as a little reminder, before we get to business, let's talk about XGeeks very shortly. XGeeks is an engineering company focused on providing capacity to product companies. We're not a typical project company due to several reasons, and that could be a live stream itself, but let's keep it to another one. But due to the fact that we have a huge focus on community, a strong engineering culture, and a great product drive. We'd like to think that we represent a great balance between projects and products. Our teams all across Portugal work in building products while dealing with the broad stack. And of course, if you want to know more about us and about XGeeks and our team, open positions, our content, and so on, would be happy to invite you to follow us on Twitter, LinkedIn, Instagram, Medium, and here, of course, on YouTube as well. We do some cool stuff. At least we like to think so, and we'd love to see you over there in those channels as well. And of course, all feedback is very much welcomed. But no further ado, I want to introduce you to our speaker of the day today. Marcus Ket is our speaker, CEO and co-founder of MicroStream. MicroStream is the very first secure serialization for Java and a native Java data store. And also Marcus is also the editor-in-chief of Java Pro magazine. So I think you'll enjoy a lot Marcus' talk about ultra-fast Java in-memory database apps and microservices with MicroStream. So Marcus will be leading today's session. So with no further ado, I'll introduce and bring Marcus to the stage. Hello, Marcus. It's nice to have you here.
Hi, Rita. Yeah, thank you so much. Thank you for the great introduction. It's a pleasure for me to be here today at XGeeks for the first time. Thank you.
Thank you so much, Marcus. We're quite excited. I'll let you take the stage. I'm not sure if you want to share your screen so that we will see it and we can add it over here. And while Marcus shares his screen, just a little note that all questions, comments, doubts are super welcome. So just feel free to leave them in the chat and we'll address them throughout the presentation and throughout the talk. So don't forget to add those. And see you in a bit. Marcus, you can take the lead. Thank you so much once again for joining us.
Thanks again. And hello, everybody. Welcome to my talk. And it's about building ultra-fast in-memory database apps and microservices with Java. That sounds a little bit complicated, right? But I hope it's not. And my goal is now to show you how you can build the fastest database apps and microservices on the planet. About me, my name is Marcus, and I'm CEO and co-founder of MicroStream. MicroStream is the company behind the MicroStream open source project. We are building Java serialization and persistence library on top of that. And I have been working with Java almost 20 years now. And before we launched the MicroStream project, I had spent, let's say, 15 years or so with developing Java development environments. So with my teams, I have built 2 complete Java development environments. The first was based on Swing. Then we migrated everything to Eclipse. This project is called RapidClipse. It's free, and the entire framework is open source also. And the goal was to enable building data-driven applications with Java in a visual way, so similar to Visual Basic or Microsoft Access or Oracle Forms or something like that. And yeah, this concept always worked really fine, and we were always happy with our GUI builder. It was simple to use, but with database programming, it was always tricky. So our users always struggled with database programming. Why? Perhaps it's because database programming in Java is challenging. And this is the reason why we tried and worked on to improve the JBoss Hibernate tools. So we worked more than 5 or 7, up to 7 years on improving the JBoss Hibernate tools. And then we started the MicroStream project to provide a fundamentally different persistence. And our dream was to provide a real Java native persistence. So a persistent for Java that feels like a Java native storage function, like a storage function that is provided by Java itself, and not like an external database system. So this is my background. And now to talk about how MicroStream works and how you can build that incredible fast applications. I like to talk a little bit about the challenges of database programming with Java today. With Java, everything, it's object-oriented, so we love it. So it's everything is type safe, so we love type safety, object-oriented programming, and clean code, a good testable code, and abstractions, no dependencies, or we love to avoid dependencies. So this is very important for us in Java. But as soon as we have to store data, then we leave this way completely, because then we have to use external database systems, and we let external database systems store our data. However, they work totally different from Java. For instance, the relational databases, they store data in tables. And now storing Java objects and or complex object graphs in tables is from technical perspective not possible. So we have a problem here. What's the problem here? So it's called object relational impedance mismatch. It's because the Java paradigm is completely different to the relational model. Why? We have a granularity mismatch here, for instance. In a relational model, we only have tables and columns. However, the object model is much more granular than the relational model, or it can be much more granular. And so this might be a problem if you want to store our objects in a relational model. Then we have a subtype mismatch. In Java, we are used to use inheritance, but in a relational model, it's not possible. Then we have an identity mismatch. In a relational model, the entities have to be identified by a primary key, but in an object model, we do not need a primary key. So this is not mandatory. So we do not need this synthetic primary key. So we have an impedance mismatch here. Then we have association mismatch. The associations are not bidirectional in a relational model. Then we have a navigation mismatch. Navigation through an object graph is very simple, but navigation through a relational model is not possible. Here we need SQL joins. So you see, there are many differences between these approaches, and so now how can this match? This is it's managed by so-called object relational mapping, but we have further challenges here. It's because of the data types. In Java, we have only some primitive types, right? But in relational databases, sometimes we have 30 or sometimes even more data types, database-specific data types. How can we handle this? So we need a mapping for that. And let's have a look on the NoSQL databases. What do you think? Are they better? I would say they are different, right? So they introduce now new data structures. For instance, key value, or a document model like JSON or XML. Or we can decide for a graph database, or we can use an object relational database that were invented in the 1980s. But when we have a look on all these databases, then they introduce data structure that are also completely incompatible with Java object graphs. So we have actually the same issues here as well. And what's about the modern in-memory databases? What's about in-memory data grids? And or what's about streaming, event streaming like Kafka? No matter what you're using to store your objects, we have always these incompatible data structure. And so in any case, we need a mapping. And for relational databases, we need an object relational mapping. And we are very lucky as Java developers, because for that we have object relational mapping frameworks. The standard is called JPA, the Java Persistence API. And the de facto standard here is Hibernate. If you use a NoSQL database, unfortunately, there is no standard, and there is no framework existing that handles these mappings for us through runtime automatically. So we need a custom mapping or a data conversion. And using these object relational mapping frameworks leads mostly to performance issues, because generating objects behind the scenes takes always lots of computing time, and this is always linked to a latency, and this slows down our system. And we handle this, or we solve this problem by adding another layer. So we add a cache layer. So we can add local cache to store result sets in memory to accelerate our query times. But even when we access directly to a local cache and read data directly from the cache, then we need an object relational mapping. So actually, we should have microsecond query time when we hit the cache, the local cache. But in practice, when we measure the time, the query time, then we will see it mostly takes also milliseconds. Why? It's because we need that object relational mapping even when we hit the cache. And so conclusion, I think this is the core problem. The data structure are incompatible, the systems are incompatible, so we need a mapping or a data conversion. Data conversion mostly takes lots of computing time. It's linked to latency. So imagine you want to watch a video, and always before you can watch the video, you have to convert the video. So it will take seconds to convert the video. So this is a latency, and it's not really a great user experience, right? But the same thing happens on our servers when we access a database. Then through every single read and write, we have these data conversions, and we need much more CPU power to handle these conversions. We can solve these problems we can increase our hardware power, but then our hardware costs also will increase. What are engineers doing if they have performance issues? Do they work on the core problem? Mostly they won't work on a core problem. It's much more simple to copy the machines. And this is what we're doing in practice, right? So if you have performance issues, if you are not able to handle the workload, copy the machines, scale horizontally, then until you are able to handle the workload. But this is the reason why mostly or very often the cloud costs increase more and more. And for us as developers, we have double effort because we have to implement the Java classes, then we have to implement the database data model. We're not able to build our object model freely, so we have to adapt our object model to the database specific data model. So this is the reason why many Java developers say, I have to develop my application around the database. Yeah, this is the reason why the architecture of database application is that complex, gets more and more complex. We have to add caching layers. We have to add local caches. Sometimes we even have to add a distributed cache. So this gets more and more complex. It's effortful for testing and deploying, and it's not really simple to test all these huge infrastructure. In Wikipedia, we have a really nice article about this problem. It's about impedance mismatch or object relational mapping, and the conclusion here is as long as the systems are different, sooner or later the developer will run always in the same, will have the same issues. Your system gets more and more complex, or your performance will go down. The question is, can we solve this problem, this core problem? And we have spent so many times about thinking about if we could solve this problem. Then we saw there is a very interesting approach already existing, and many Java developers they have already thought about, and this is called system prevalence. Have you ever heard about system prevalence? But serialization, this is definitely a great idea, and many Java developers have already thought about, hey, I can use serialization to store and load my objects. And this is how system prevalence actually works. So with system prevalence, the system state is kept in the memory in a binary format. And by using snapshots, the system state is stored persistently on disk. And this is the easiest and fastest way to get ACID persistence for your Java objects. Here is the functional principle and the architecture. you only need your Java object, your Java app or a microservice written in Java. Then you have your objects in memory, or you have your complex object graph in memory. And then you use Java serialization for your snapshots. And then you snapshot your Java object graph and store it in a binary format persistently in a plain file storage. Super simple. It's core Java. It will be very fast if you have to work on your data. Then you can now query your data in memory. And to query your data in memory, you can use Java Streams API, for instance. And so everything is executed very fast in memory. It's core Java. But perhaps there will be some challenges, right? And here I have a list. It's there are only some challenges linked with snapshots. So, and perhaps this is the reason why this concept system prevalence is not that popular in practice, right? So why? Of course, if you use snapshots, then the bigger your database or your data in-memory database becomes, then the slower your snapshot will be. So the problem is the snapshot size, and the snapshot time is always a problem. And between the snapshots, you can lose data. So this is not really great. And if you want to build a microservice, then it's very important that you have very fast startup times. And if you have to restart your service, and you have to reload the entire object graph again and restore it in memory, that might take too much time. So this concept is not suited for microservices. And your database size is limited to your RAM size. So this might also be a problem. And think about if you use snapshots and store your entire database all the time with snapshotting, then you produce tons of traffic on the wire. So this will increase your infrastructure costs. Then if your database size becomes bigger and bigger, then you need more memory size, and then sooner or later you will have concerns about the garbage collector issues. And then there are tons of further challenges, like what is if my classes change? Okay, we can stop here because this might be a great idea, and this might be super easy to use, much simpler than object relational mapping frameworks, but there are too many challenges. Now, with MicroStream, we have eliminated all of these problems. And then this is a game changer. How does it work? Here we have the architecture of MicroStream. We have an application or a microservice written in Java again. We have our objects or our object graph in memory. Then we only need a MicroStream, which is a tiny Java library you can download via Maven, include in your project very easily. Then we need a JVM. And then you can choose your storage strategy. So you can use plain files, but with MicroStream, you also can use a relational database to store and to persist your object graph. But it's very important to repeat this at this point. You can use a relational database, but we do not use the relational model anymore. because we store binaries. So we are able to store binaries with a relational database. So we have a connector, we can use a relational database. But we also can use NoSQL databases to store our binaries. So now we have system prevalence with MicroStream. We can choose any data storage. But the main difference here is that we don't have to snapshot the entire object graph, the entire database. We can now store single objects, or in practice, mostly subgraphs, and which means any object reference can be stored. And with MicroStream, we only store the changed objects. So only the delta will be stored, will be serialized to the storage. And this is really a game changer. Now, we don't need any mappings behind the scenes. So mappings eliminated. We don't need any data conversion behind the scenes. So we save here lots of computing time, and we save lots of CPU power and cost of infrastructure by eliminating these conversions behind the scenes. Yeah, it's an interesting number. We have really projects where we save up to 90% cost of infrastructure with this concept. How does MicroStream work internally? MicroStream is a serialization, but we do not use the Java, the traditional Java serialization, because we would not be able to do this with Java serialization. So MicroStream is a fundamentally new written serialization. On top of that, we built a persistence library for the JVM. And we also have a implementation for Android. So if you want to persist your objects on Android, then you can choose MicroStream as well. So it works completely the same way than on the JVM. But this is not topic of today. On top of that, we have much more functions like legacy type mapping. So we call it legacy type mapping. This is actually a class change handling. So if your classes change, don't worry, MicroStream cares for that. Then we added a file system garbage collector. Why? It's because we store binary data, so we store the types appended to the file storage. And if you, as soon as your classes change, then you will have different versions of your classes and different versions of your objects in a storage. This can be an advantage, so because you get versioning out of the box, but your storage will grow more and more. And with the garbage collector, the MicroStream garbage collector, you can remove your legacy objects from a storage. And this works a little bit similar to the JVM garbage collector, but it works on file storage base. Then we have a file system abstraction, and we have database connectors, so that you're able to use relational database, NoSQL database, or store your binaries in Kafka. So that's possible with the database connectors. To enable access to the storage data, we provide a REST interface. And on top of the REST interface, we provide a graphical user interface you can use to browse through your storage data. Yeah, actually all major databases are supported or are work in progress. And MicroStream runs actually wherever Java runs. It runs on of course, desktop servers. It runs in the cloud. It runs in a container. It runs on Android, and it runs also on GraalVM native images. So this is very important if you build microservices with a microservice framework. You can run it with GraalVM native images as well. And the only requirement is Java version 8. You can use any JVM language, and I mentioned Android as well. Let's have a look on the code. Here we can see a simple class, and what we see is nothing specific. And this is the big benefit of MicroStream. I would say I have never seen a storage solution that enables you to get persistence for your objects with writing so less code. It's so easy. So here we can see there are no specific annotations needed. There are no interfaces you have to implement, no superclasses you have to use. Just POJOs. So use your Java classes as they are. You can use any Java type that is suited to be persisted. You can use you can persist objects of third-party APIs. You can create your class structure as completely freely. So build your object model freely. MicroStream does not force you to do any specific design. There are no design things you have to do. So really easy to implement your data model or your Java classes. I mentioned it already that you can build your object model freely. So you need an object graph, and for that you only need a root object, and it's similar to a swing tree, let's say. So you have a root object, and then you can add any Java type. You can store only one single object. You can store a list. You can store collections. You can combine all these types. You can build up a complex object graph with circular references. You can use inheritance. So build whatever you like. If you want to store an object, or mostly a subgraph, then you only have to store, or you have to call one store method, and you always have to call the store method at the owner object. So which means if you have a collection and you change some object in your collection, then you have to store the collection. And MicroStream only stores the changed objects. So this is the difference to the initial system prevalence concept, where the entire object graph is serialized. So MicroStream only stores the delta. Only the changed objects are stored persistently on disk, and each store is an atomic operation, and it stores the subgraph appended in a binary format, appended to the file storage. And yeah, this is an atomic operation. It's transaction safe, and it's executed very fast because there is no data conversion behind the scenes. So MicroStream serialization is very fast. It's up to 25 times faster than Java serialization. It's almost that fast as your hardware will be. So here we can see if I call the store method, then MicroStream will append the types that my objects to append it to the file storage in a binary format. Then you can use channels. What are channels? Channels are kind of like multi-threaded I/O operations. So the more cores your hardware supports, the faster will I/O operations be executed. This is provided by channels. When you start your application, then MicroStream loads initially the entire object graph in the memory, but only the structure of your object graph is loaded, which means MicroStream loads only the object IDs into the memory initially. And this is the standard behavior. So even if you have, let's say, terabyte or even more data in your database and in your object graph, then only the object IDs will be loaded. You will get a fully indexed object graph in the memory, and then you can decide which object references you want to load initially into the memory and which object references you want to load only on demand when needed by using lazy loading. And here you can decide by marking your classes as lazy. And if you when you load data in a memory, then here you have the same. It's multi-threaded. You can use channels for load your object references in the memory. So this will be also very fast, executed very fast. And what's interesting is that if you load a subgraph, for instance, in a memory, then the object references will automatically merged into your object graph. So there are no object copies. So you don't have to deal with object copies. This is very convenient programming model. Yeah, because now you only have to call get methods and that's it. So there are no more classic selects if you want to load data. So no more classic selects, just call getter, and then MicroStream loads the object references into the memory by lazy or eager loading. You decide as a developer by marking your classes with lazy or not. Once again, because this is very, very important. With MicroStream, you always have two options. Number one is you have a small database, let's say 100 gigabyte or only 1 gigabyte, a small database, and you have enough memory. Okay, you have enough memory. What are your options? Then you can load the entire database in your memory. But it depends on the use case. So if you build a monolithic application and you start it once and run it for 2 years or so, then you can do that. You can load the entire database in the memory. Then you have all data in the memory. You create your object graph with Streams API, super fast. You get the no latency application. Fantastic. Then you can do that. If you want to build a microservice, then you should not do that. Then you need a very fast startup time. Then you should use lazy loading. So it depends on the use case. It depends on the size of your database, and it depends on the size of your memory. Now, if you have a very huge database and you only have some gigabyte of memory, let's say you have a terabyte database size and you have only 4 gigabyte memory, then you cannot load the entire database in the memory, of course, then you should use lazy loading, mark your classes as lazy. You only load the most important data initially in the memory, and all other object references you should load by using lazy loading. And this is the right concept if you want to build microservices. Then this is important that you have very fast startup time. So it depends on the use case, and with MicroStream, you have these two options. You decide if you want to load, how many data you want to load initially into the memory.
Marcus, sorry to interrupt you, but we have some questions. Should I put them now? Is
Yeah,
that
great.
okay? Okay, perfect. Thank you. So this question is from Pedro Seirat. Pedro, thank you so much for your question. Pedro asks, mentions that, hi Marcus, first of all, and hi everyone. I have a question about the snapshots. Since you only store the deltas, it will improve the storing phase, but reading stays the same, or with that change, it's also improved. And Pedro also asked, regarding the frequency of the snapshots, is it handled by the programmer or can be configured?
Yeah, first of all, the programmer always decides about what is stored and in which way is it stored. So you decide if you which object references do you want to store and when do you store that. And MicroStream stores the delta automatically. So it's everything is done by the engine automatically behind the scenes. Reading stays the same. Changes. I don't know if I have understood this question correctly, but as I mentioned, it always stores only the. No, I'm sorry. You can really decide if you want to store the deltas, but you also can store everything. So you have full control about how the engine works. So you decide. But in practice, you mostly will store only the deltas. So it's much more performant, and you should avoid storing single objects. So this is not recommended to store every single object. So you should then execute more store operations or store a collection and avoid storing single objects. But you can do that.
Thank you, Marcus. And thank you also, Pedro, for your question. And thank you, Marcus, for your answer. Go ahead.
You're welcome. Yeah, and with by using MicroStream now, we have the chance to work on our object graph. So now our object graph becomes an in-memory database, right? And how can we query an object graph? So MicroStream does not provide a query language. It's not mandatory because we have Streams API. And at the beginning, I mentioned we love type safety, right? But I saw many apps where the programmers use JPQL for writing queries, and then you see these native SQLs. So with Hibernate, you can use native SQL, right? And mostly you will have these SQL strings. Oh, this is not really type safe, and actually we hate it to include strings in our Java code. There is no IDE support. It's not good testable. But as soon as we query a database, then that's okay. But with Streams API, don't worry. It's completely type safe. It's fully object oriented. it's core Java, and what is most interesting, the Streams API, super fast. It's really incredible. You can have really huge object graphs and let's say 250 gigabyte or even bigger memory size, and you can query your object graph in microseconds. This is incredible. Believe it or not, I have a performance demo for you. Yeah, let's have a look on this performance demo. And by the way, you can download the code on GitHub, play around. You can create test data and play around, implement queries as you like. Here we have two apps running in parallel. It's a bookstore demo, and we have about here 250 gigabyte of data, and we use an Oracle database. Then one application is built with Hibernate and EH cache. And because this application is running all the time, it's a hot EH cache. So here we hit the cache. And we see it's a yellow bar, and we see the query time, we see the query code. It's the JPA on the right side, the JPA query code. It's, by the way, built with Spring Data. The second application is built with MicroStream. No cache is needed here. And we load the object references in the memory, then we query the memory, the object graph in memory with Streams API. Here we see the Streams API code, and all queries are executed sometimes 10 times faster, sometimes 200 times faster, and sometimes more than 1,000 times faster. So this is the power of the JVM. This is the power of Streams API and the power of Java in-memory computing. And so when I saw this for the very first time, then I thought this must be a mistake. But it's not. It's this is the performance of our JVM. And MicroStream is the only missing piece of puzzle that allows you now to store and load your object graph. That's it. That's all. Do I have to care for memory management? No, you don't have to care for memory management. Everything is done by the JVM. The only thing is you decide which object references you want to load lazy in the memory. So you can load the object references, and then you are able to clear the lazy references to save memory if needed. So you fully control about your lazy references. If you have concerns about garbage collector pauses, we work very close together with Azul. So Azul really are great partners. And Azul says they are able to manage up to 20 terabyte memory size without garbage collector issues. Check it out. It's really incredible. So mostly we don't need 20 terabyte of RAM. So in our customer projects, we see mostly instances with 4 or up to 16 gigabyte memory, and that's mostly enough for our applications. But it depends on the use case. But it's a great message is we can also deal with huge memory sizes without garbage collector issues today. Here is an example how the MicroStream garbage collection works. So if your classes change, then MicroStream will handle this automatically behind the scenes with we call it legacy type mapping. So MicroStream handles this automatically, and if you change objects, then you can use a legacy type mapping. You can use a custom type mapping. Then you store the object again, so you change your class. Then the new object is loaded in memory. MicroStream loads the object in the memory and then recognizes that the class has changed, then handles the class changes automatically behind the scenes, and then you store the object again, and then you have a new version of your object in your storage. And then you have different versions of your objects. Then you can configure the garbage collector that it removes the legacy, the old versions, automatically from your storage and cleans up your storage behind the scenes. So with MicroStream in system prevalence concept, you will you will have a paradigm shift in database programming, of course, and you should think about that. So you have to think a little bit different. Here we have the traditional database server paradigm. You have a Java application, you have your Java server, then you have the database server, and the database is located on your database server, and you always will query your database. The only exception is if you hit a local cache, but mostly you will query the database on a database server. With MicroStream, it's a different paradigm, and it works a little bit different. With MicroStream, you only have your persisted data in your file storage or in your database on a database server. We load the object references from the database server into the memory, and then our object graph becomes our in-memory database, which means our database is located in memory. It's located in the Java server, and then we query the object graph. So the queries are executed in the Java server. So this is the paradigm shift. Are there challenges with MicroStream? Oh yes, there are challenges with MicroStream because I think with all solutions you have challenges as well. But I have to search for the slides. I cannot find the slide with the challenges. So, but it's easy. We have challenges as well. So you have to be a Java programmer. That's it. It's not suited for DBA. So if you're a DBA, you will hate MicroStream mostly. So it's really built for Java developers, and it was really built for Java. And we don't want to build the next database system that forces you to adapt your classes and your object model to a specific database model. And there's another thing. You have to care for concurrency. So, but what we have learned in the last 20 years of building development environments for database-driven applications, that Java developers mostly care for concurrencies anyway. And you have to care for validation, concurrency. So this is important. And these are I would say the biggest challenges with MicroStream. And you have to rethink the way you build your object model. With the relational database, you're limited in a way of how you can build your object, your database model. With MicroStream and with plain Java, you can build your object model completely freely. So do whatever you want, and it will work. So you have to think about how you organize and how you structure your data. But you can do this really freely. Lastly, with MicroStream, you don't only have a persistence library. With MicroStream, you also have a pure Java serialization. And this is also very interesting. Why? Because Java serialization is really a high security risk. And Mark Reynolds said that Java serialization was a horrible mistake, and 50% of all vulnerabilities in Java are linked to Java serialization. And Java serialization is used by almost all frameworks, all libraries, all Java applications use Java serialization under the hood. What's the problem here? With Java serialization, not only data are transferred, with Java serialization, also metadata of your classes are transferred. And this allows the bad guys to inject code and execute malicious code through deserialization. And so this is very easy to, and you don't have to be a hacker. So you can generate this code with tools you can find in the internet. So it's scary easy. So you can inject code, and so you can destroy your Java application through deserialization. There was a very famous there was do you remember Equifax? So this was a security leak in Struts, and so this was a very famous example. And of course, Java serialization is limited, so you have to objects have to be have to implement the interface serializable. You can not serialize objects from third-party libraries that are not implement the interface serializable, and so on and so on. And Java serialization is not really fast. With MicroStream serialization, now you have you get a serialization that is works fundamentally different. MicroStream transfers data only; no metadata are transferred. So it's completely impossible to inject malicious and to inject and execute malicious code through deserialization with MicroStream. So here the biggest security issue of Java is eliminated. And if you want to build up a high secure application or framework, then you should check out MicroStream. It works different from Java serialization, and maybe it will help you to secure your Java applications. Okay, last important thing is MicroStream is built as a single to build single node applications. So you have one app that accesses exactly one storage when you store data. Currently, we're working on a cluster, MicroStream cluster. So we work on replication, and it's already running as a prototype. We will introduce this at our MicroStream Summit on November 4th. It's a free online conference. You can register for free. We will introduce cluster. We will introduce MicroStream Cloud. We will have great speakers, so you can join for free. Okay, that was MicroStream in a nutshell. I hope we're still in time.
We're still in time, Marcus. Just right
Fantastic.
on time. Right
Okay.
on time. Thank you so much, Marcus. It was awesome to have this presentation of yours, and also thank you for sharing with us this perspective of yours, and also thank you to everyone that joins today's session. We hope to see you again next week. And once again, if you have any questions for Marcus, you can also find him on Twitter. So if you want to drop him a message, you can feel free to do so. I'm saying this on behalf of you, Marcus, but I think people can reach out to you, right? In case they have any questions or comments that they would like to see covered, correct? Okay.
Thank you for having me.
Perfect. Thank you so much, Marcus. It was nice to have you. And thank you to everyone that joined. And we'll keep you posted on upcoming events. Bye, everyone. Ciao.
Thank you. Goodbye.